Hi, I'm Jenny Noonan, Director of the Policy Analysis and Communication Group at EPA's Office of Air Quality Planning and Standards. Thank you for joining us for the live portion of this broadcast. I'm joined here in the studio in Raleigh, North Carolina, with Dale Everts. He's the leader of the Climate International and Multimedia Group at EPA's Office of Air Quality Planning and Standards, also known as OAQPS.
Thank you, Jenny.
I'm also pleased to be joined by Tyler Fox, who's the leader of the Air Quality Modeling Group at OAQPS.
Thanks, Jenny.
And Rhea Jones is here, and she leads the Geographic Strategies Group at OAQPS.
Thank you, Jenny.
And I'm also pleased to be joined by Dr. Alice Gilliland, Chief of the Applied Modeling Branch, Atmospheric Modeling and Analysis Group, Office of Research and Development here at EPA.
Thanks, Jenny.
Thank you all for joining us here today. We just had a wonderful group of segments talking about some of the science and a little bit of the policy of climate change. And I'd like, for our audience's sake, to turn to you, Dr. Gilliland, first. And just for the sake of clarity, Dr. Jacob referred to a couple of terms that I want to make sure our audience understands. And the first is, and you also referred to them, black carbon. Could you give a brief explanation of what black carbon is?
Sure. Black carbon is one of the PM2.5 species, and it is directly emitted from several types of sources. Some of the key ones would be diesel vehicles and combustion sources and biomass burning.
Okay, great.
And so it's not chemically active.
Okay. And one of the other words that he used, or expressions that he used, was a cyclone. And I know that in colloquial English that has a specific set of meanings, and I was just wondering if you could elaborate on what he was referring to when he said cyclone.
Okay. He was really focusing on the cold fronts, the weather passages across the U.S., and that in a lot of the future climate simulations, actually some of the ones that came out from his group in publications showed a decrease in the frequency of those cold front passages, and so it caused increases in stagnation events, which we know tends to contribute to higher ozone, high pollution events.
And I'd like to get right to questions that we have coming in from callers. And if anyone would like to add a question, they can call 1-888-228-6736, or you can email us at epa@doa.nc.gov. And there's also a fax number, if you'd like to fax in your questions, 919-715-3569. So Dr. Gilliland, let's get back to the first caller from Tennessee. Considering that the Earth is constantly going through natural warming and cooling fluctuations, how can we quantify the extent of human impact on what might be a natural warming trend?
Well, Judy, there's a lot of research out there looking both at observations and modeling studies to assess how much human influence there is on the climate change that has been seen. And there is general consensus in the scientific community that there is a human influence on climate change. And there's a good document, the IPCC, Intergovernmental Panel on Climate Change, Fourth Assessment Report that came out last year, 2007, that has a great deal of discussion and description, graphic evidence that they show to discuss humans' role in climate change. And regardless of what the added causes of for anthropogenic versus natural, we do know that there is going to be interactions and influence on air quality from future climate change.
Great. And I would like to make sure that everyone knows the email address. It's open@doa.nc.gov. One of the themes that we heard in the first part of the broadcast and that will continue throughout this broadcast is how EPA is working with others about climate change. And I would describe it as three things. One is that building frameworks, especially multi-pollutant frameworks, fostering collaboration between all levels of government and communities, and then also creating and disseminating tools for state and locals to use. And I know that all of you have some experience with that. And Rhea, I'd like to talk to you a little bit about this. Leah Weiss from NESCOM referenced a project with the state of New York, and she called it, I think, the AQMP program. Can you tell us a little bit about what that is and our involvement with it?
Sure. AQMP stands for Air Quality Management Plan, and it's an initiative that EPA has taken on to help us move towards multi-pollutant planning. Our Clean Air Act Advisory Committee has actually recommended that we move away from our stovepipe approach to air quality planning, where we look at air quality impacts one pollutant at a time to a more comprehensive multi-pollutant air quality planning process, and the AQMP is responsive to that recommendation. An AQMP is a set of pollution control strategies and planning activities that would help an area or a state demonstrate how they will attain and maintain the national ambient air quality standards, to demonstrate risk reductions from exposure to toxic air pollutants, to improve visibility in ecosystems, and also integrate those things that aren't normally included in air quality planning but impact air quality, like transportation, land use, energy efficiency and energy use, and climate plans. And so the AQMP process is a process to help to initiate that comprehensive planning, to provide that process for states to use. Now, states are already required to submit state implementation plans to demonstrate attainment with the national ambient air quality standards, but it's done one pollutant at a time. We're hoping to achieve some efficiencies here with the comprehensive air quality planning process, that it won't replace the state implementation plans at this point, but it would provide a mechanism and a process for states to conduct their air quality planning, considering multiple pollutants in one place comprehensively. So parts of this AQMP could be used to satisfy those SIP requirements or state implementation plan requirements, but would be used as that mechanism to help move towards that framework for multi-pollutant planning.
Okay, that's very helpful. And in fact, it leads right into a question also from Tennessee. Given that budgets have been shrinking over the past years on all levels, national, state, and local, how does EPA plan to fund an added program of air quality and climate change while continuing to fund the current criteria pollutant programs?
Yeah, it's an interesting question that they ask, and we actually are considering that as well. We believe that as you integrate air quality planning away from just looking at one pollutant, one phase at a time, and looking at them together, that will get some efficiencies and actually result in reduced level of effort, or FTE, save money and time and resources. And so as integrated planning moves forward, we expect that costs for implementing air programs would decrease. And we actually have a pilot effort in place now to test that. New York is one of our pilot areas that will be testing this. And in the end, we will see if we can realize that through this multi-pollutant planning process. The states that are participating in the AQMP process are using their own resources, and it's at their discretion that they're conducting the AQMP process. And so this will be a good test to see if they can compare what they would have done normally to the multi-pollutant planning process to see if they save time and resources.
And in the New York example, is climate a part of the project?
Climate is definitely a part of the project. New York is actually starting from the climate aspect to determine the climate, other air quality impacts from the climate perspective, and they're working with NESCOM on that through their multi-pollutant framework with the climate focus to help determine impacts on other air pollutants as well. So they're one of the pilots that we're tracking closely to see how they're integrating climate planning into air quality planning.
And Tyler, are there any technical projects or related work to support the AQMP pilot?
Yes, in fact, we're working in the Detroit metropolitan area to conduct what we call a test bed, where we take our existing data, tools, and models and try and apply them in that urban area to address the concerns that Rhea mentioned under the AQMP project, but extend those data, tools, and models to be able to address those multi-pollutant needs from an assessment standpoint. That, of course, includes the inventory and having an integrated inventory, feeding that into a one-atmosphere air quality model like CMAQ that was mentioned earlier, the community multi-scale air quality model that our Office of Research and Development is responsible for development of, and then using the results of that modeling to feed into health and risk assessments that another part of OEQPS works with Dale and others with their BenMap tool to evaluate those things from a incidence of health and risk and valuation of those benefits. That will be used as a starting point for some of these pilot areas, but it will be an input into that process because they will need to tailor the analytics to the concern that they have. Rhea mentioned the work in New York is really being driven by the desire to integrate climate and air quality planning. The other areas have other drivers, if you will. that would be bringing that forward, such as North Carolina looking at land use and other types of issues, and St. Louis looking at really some of the issues in terms of criteria near toxics causing local problems in that particular area. So as Lee Weiss mentioned, New York will be using that framework to drive and then consider those climate programs with an air quality planning aspects brought into it, which is, broadly speaking, multi-pollutant, and bringing those climate considerations effectively into that planning process, and hopefully improve decision-making as part of that through the analytical information that we can provide.
And how does one become a part of the AQMP? For any of the listeners out there, if they wanted to try this, we're thinking about a multi-pollutant approach, how would they get involved?
Well, right now we are under a pilot program, and it was initiated back in 2007, where we solicited for volunteers to participate among the states to participate in the AQMP process. We've selected 3 areas: New York for the state of New York, North Carolina for the entire state of North Carolina, and Illinois and Missouri participating for the benefit of the St. Louis area. And so this pilot effort would conclude in 2009 with the areas completing their plans and starting implementation of those plans. But for other areas who are interested in the process, they can follow us along by following the information that we include on our websites. The website for the AQMP process is www.epa.gov/air/AQMP/. And so we'll be posting information there as we make progress with the areas in the planning process that other areas can follow. One of the goals of the AQMP process is to have something that in the end is transferable. We want to have a real life example of how multi-pollutant planning can be done and be successful. And we want to make sure that once it is successful, it can be transferable to other areas. So at the end of the pilot, we hope to have a product that we can share broadly with states and areas that they could apply in their areas as well.
So the areas were St. Louis, New York, North Carolina?
Correct.
Those are the 3?
Correct.
And the states of Illinois and Missouri are coming together in the St. Louis area as part of this pilot area.
Yeah, and all of these areas are working with their stakeholders to make sure that they're getting their input and insight, understand the goals of the AQMP process, and can get buy-in as they move forward with their control strategy planning and their air quality planning strategies as well. So.
And that's an important aspect. Like in St. Louis, the East-West Gateway is playing an important role. So as these areas look to their local public and others to provide input and stakeholders, that'll be a critical part of this process.
And Dale, we've heard a lot today from both Dr. Gilliland and also Dr. Jacob about ozone and the relationship between traditional air pollutants such as ozone and climate change. And I wanted to get a little bit more of a policy perspective on that. Based on the discussion, some of the traditional NAAQS pollutants, like ozone, appear to have significant impacts on climate. How does EPA plan to take this into account in future standard setting efforts, for example, the NAAQS?
Okay, well, that's an excellent question. As you know, we set NAAQS on a regular basis every 5 years, or we review our NAAQS, our major national ambient air quality standards. And as part of that review, we take into account information on, for instance, with ozone, which is about to start again with another review, take into account and we'll be looking for information, soliciting information, and including information on ozone impacts on climate as well as climate impacts on ozone. So that's a significant part of the review and something that we will consider as we go through this latest review with ozone.
And do you think, given the rate at which global temperatures are rising, does EPA think that this will impact the ability of some local areas to attain the new ozone standards, the ones we set in 2008?
What our current modeling is not refined enough to show us exactly the location and magnitude of the effect of climate on particular areas. However, what we're seeing with the models, and Tyler and Alice could say some more on this perhaps, is a fairly robust finding that the controls that are in place right now are sufficient to meet our air quality standards, or the ozone standard. In terms of ozone, however, we have just recently revised the standard. It's now 0.075 parts per million. As the climate warms, as you saw in these presentations, as the climate warms, it's more likely to create ozone in certain areas. The location, again, is not clear based on our modeling yet, but there's likely to be increases in ozone, and it'll be more difficult to meet those standards. So the specifics in terms of what areas we'll have to do needs to be watched very closely here over the next few years.
Okay. I have a question from New Jersey for Dr. Gilliland. If I understand correctly, the results that you are talking about in your presentation, namely increasing ozone levels in the future, are based on modeling studies which do not take ozone emission reduction control strategies into account. If this is true, aren't there studies which have modeled emission reductions and their effect on ozone levels in a future climate?
Yes, okay, so that's a very good question. In the studies that I was discussing, these were global scale chemistry models that were using assumptions from the IPCC A1B scenario. And in the A1B scenario, there are decreases in NOx. A lot of the increases that we were seeing in those modeling results were because of increases in black carbon and changes in sulfate that actually have a scattering effect, and whether or not you believe sulfate is going to go down or up. So it's really more on a global scale that they were seeing that collectively these air pollutants contributed to an increase in temperature. Now, on a regional scale, on the U.S., for example, where we're looking at policies and emission control strategies, there have been studies looking at more of this continental U.S., what impact would there be from large decreases in NOx, and you do see decreases in ozone. I think it's an issue of scale where you're looking at national versus global impacts from some of these pollutants. And the main thing I would highlight from what we talked about from the synthesis and assessment report is black carbon. There's a lot of uncertainty about how black carbon will change in the future, but it has a warming effect. In most of the U.S. policies for ozone, we expect that ozone should go down. So I think it's more of a concern about transport of black carbon, and how black carbon will change in the future is something to look at more on the regional scale as well as the local. Now, what we did see on the regional scale modeling that was also interesting is that when you look at what kind of policy changes would impact ozone, you have more effective decrease in ozone if you didn't have climate change. So this goes a little bit to what Dr. Jacob was talking about in his part of the session, where if you look at a scenario of emission changes, emission decreases for ozone regulation, and you don't consider the impact of climate change on it, you would have a more effective control of ozone. But then if you say what would happen if you also have the climate trends that the models project, you wouldn't have as much of an improvement in ozone.
And on that same sort of topic, Dale, is there much overlap between greenhouse gases and traditional air pollutants in terms of sources and controls?
Short answer, yes. It's as Steve, I think, said in the lead up to this program, Steve Page, the sources such as electric power, cars, automobiles, energy-intensive industries all emit both criteria pollutants, in some cases air toxics, as well as greenhouse gases. And so, and that's one of the chief reasons for approaching these issues together in an integrated fashion. Now, one of the things we're finding out about controls is, yes, there's some overlap in controls for both greenhouse gases and the traditional air pollutants, but in some cases you get a conflict. For instance, with scrubbers for power plants for scrubbing SO2 from the waste stream, you get that and diesel particulate filters that are used to control diesel particulates from some vehicles. Both of those cost energy to operate, and so indirectly lead to an increase in greenhouse gases. However, there's a number of win-win situations, for instance, energy efficiency measures, where and wind and solar, which actually don't emit any greenhouse gases or air pollutants, where you get can get significant reductions in both greenhouse gases and the traditional air pollutants. And what we're trying to do with our analytical tools is tease out those win-win situations, while at the same time getting a better understanding of where there might be conflicts, where one approach may cause actually an increase in either greenhouse gases or traditional air pollutants.
And to go back to you, Dr. Gilliland, we have a question from California. And this question is, can you explain the mechanism of how methane increases background ozone levels?
Sure. Well, methane, similar to non-methane hydrocarbons, is a precursor that contributes to the production of ozone. And the reason that it's more of a background contribution is that methane is a more long-lived species, it's more stable in the atmosphere, and it gets very well mixed. And so when you're looking at its contribution to ozone, it's not that it causes high-frequency peaks or high elevations of ozone at a short time scale, but more of the average ozone levels that you're seeing across the summer, for example.
And in general, the levels of methane emissions for anyone here, are emissions of methane generally going up, or what are we seeing about emissions of methane?
I believe in IPCC projections they're going up. Now, I think within the U.S., and this isn't something for me to answer, but I think there are some, at least voluntary things being considered to try to reduce methane emissions in the U.S.
Okay. And for anyone who has other questions, please call us at 1-888-228-6736. And we also have an email address, which you can email us at open@doa.nc.gov. And if you are near a fax machine, please fax in your questions at 919-715-3569. And Tyler, let me ask you, will EPA be issuing any guidance to states on how to incorporate climate considerations in their modelings for SIP planning, SIP demonstrations?
Excellent question. The modeling group at OEQPS is responsible for providing model guidance, or how you use those models to regional, state, local, and tribal entities for their SIP demonstrations. Currently, we don't have any account for climate change considerations in what we would currently recommend these states model for their ozone, PM2.5, and regional haze SIPs. However, given the recent revisions to the ozone standard and the PM2.5 standards, particularly the daily standard, we'll be looking at revising that guidance. And certainly, as part of those revisions, we'll be trying to take into account recommendations to those entities in how to account for climate considerations. But I think what we need to remind ourselves is that until we get a full understanding of the implications of climate change on ozone and PM2.5 and even regional haze, and then have an ability to account for that through our modeling system and connecting that with what the states will be using, we're probably not going to provide specific recommendations. We'll probably be providing general type of considerations that they should put in place. And in fact, currently, we have weight of evidence provisions within the guidance that allow for states to bring other aspects, other technical considerations as part of their demonstration to help in understanding how they may attain these standards, or considerations that they are bringing to light in developing the control strategies to meet those standards. So certainly climate change can be brought in currently under those weight of evidence type of demonstrations, but we'll be taking it up in the next round of revisions.
Dr. Gilliland, back to you. One of the first question that we got today, which was talking about how much do we know about man-made effects, and a lot of that I think stems from questions about uncertainties and surrounding the modeling. And a question I have is, there are many uncertainties when projecting the future in climate. Mm-hmm. And what are the main uncertainties affecting the influence of short-lived pollutants on climate?
The two largest uncertainties are how the emissions will change in the future. There's a lot of ifs in those scenarios, and we need to consider a range of scenarios. And the other one is the indirect effects of PM2.5 aerosols on clouds. And that we talked about a little bit in the session, that's a part of the modeling that is very uncertain and is under research and development right now to how to capture that in a global scale model.
Okay, this question goes to either Tyler or Alice, so take your pick. This question comes from Mecklenburg County here in North Carolina. During the first half of the teleconference, it was stated that increased climate will impact the planetary boundary layer and increase ozone formation. However, it would seem as though increased temperature in the troposphere would cause an expansion or increase of the troposphere and thus cause greater dispersion of ozone precursors. If this happens, the lack of concentration should reduce ozone formation, especially at ground level.
I'll allow Dr. Gilman to take that.
So if I understand the question, the person is asking that the planetary boundary layer, if it increases, shouldn't that disperse the pollutants more? And if that were the only mechanism causing a change in ozone, that connection would make sense. What we saw in our modeling studies is that the increase in temperature, which affects the chemistry, and also a key thing was that there was large changes in solar radiation reaching the Earth's surface. And ozone production is a photochemical process. So both of those two drivers were the biggest ones introducing larger, causing larger ozone increases in our modeling results. And further, in the global scale simulations that Dr. Jacob was talking about, their global climate model had a lot more stagnation. And regardless of what your PBLs are doing, your planetary boundary layers are doing, if you're not cleaning out that air, bringing it across the U.S., and it's building up the pollution, then you're basically introducing the perfect conditions to produce more ozone. So those were a lot of the driving factors.
Anything to add, Tyler?
Yeah, I would just add that I think this illustrates the complex situation we're dealing with climate, and that it's important not to look at one piece of the puzzle because it is such an integrated situation, and you really need to collectively look at all of these interactions that are going on in order to ultimately determine what really is going to happen with ozone and PM and visibility. These kind of partial views of things can in some cases maybe indicate something that really isn't going to happen in reality, and that's the focus of our efforts, to try and make sure that our models can capture these things in a very complete and accurate way, and certainly working on improving those things.
Okay. Well, I'd also like to remind our viewers that if you would like a copy of the slides that were used in today's presentation, either to follow along in the second half or to review the materials that were in the first half, please go to our website, which is www.epa.gov/APTI. That's APTI. And that will allow you to, as I said, download any of the slides that were shown in today's broadcast. And in addition, it will provide the location for this broadcast itself will be posted in about a week. So you'll be able to watch it later and share it with your friends. And now that concludes our first panel. I'd like to thank all of you for joining me. It's been a true pleasure. And for the viewing audience, I encourage you to stay tuned with us, because we're going to have the second half of the show and a second live panel at the end. And that's all we have that's all the time we have for questions. Thank you so much for sending them in. And I encourage you to continue sending them in as you're watching the second half of our broadcast. So thank you so much for joining us, and we'll see you after the second half.